Children, let us begin with our Science 1 session 4 for chapter number first, motion. Okay, so already we have discussed about distance, displacement, speed, velocity. Okay, so distance, displacement are different physical quantities. Okay, and speed and velocity are different physical quantities. We have already studied about scalar and vector quantities, why distance and speed is called scalar quantity and why displacement and velocity is called as vector quantities. Okay, now let us go for average speed. That also already we have studied in the previous session. Average speed, how to find average speed, how to find total speed. So speed is nothing but distance upon time. Speed is equal to distance upon time. Okay, so if there are number of distance which is not constant means changing. Suppose 1 kilometer, 1.5 kilometer, 0.5 kilometer, 2 kilometer, 2.5 kilometer and so on. So this is changing distance and time is in fixed time interval. Okay, so per hour it is changing its distance. So we can say that that speed is called as variable speed. It is not changing in constant form or it is not having uniform motion or uniform speed. Okay, but to find that speed and speed for uniform motion and speed for non-uniform motion is different to find. Okay, if the speed is for uniform motion, so it's very simple, directly you can take any one value and divide by the time given. Suppose in the previous class we have seen one example also for that. Okay, and if the motion is non-uniform, for non-uniform motion what you have to do, you have to add all the given quantities d1 plus d2 plus d3 plus d4 and so on, divided by t1 plus t2 plus t3 plus t4 and so on. Okay, for non-uniform, or I can say for variable motion. Variable means changing motion. Okay, and for uniform speed, the distance, any distance you can take divided by time. Okay, in the same way for velocity also. Okay, so we have studied in the previous class that velocity is equal to displacement upon time. Displacement upon time. Okay, here the same, velocity for uniform motion and velocity for non-uniform motion. Non-uniform motion can be called as variable also. Okay, for variable motion. So same method you will use. Displacement d1 plus displacement d2 plus displacement d3 plus and so on, divided by t1 plus t2 plus t3 and so on. Okay, for variable same method. Okay, but if we are having constant change, displacement is having constant change means after every second the displacement is 1 meter in north direction. So direction is not changing, plus its distance is also not changing. So hence this displacement is a uniform motion. Velocity having uniform motion, you have to take average of initial and final values. Okay, so the direct formula you can use here for average velocity, that is initial velocity plus final velocity upon 2. So it is average. How to find average velocity or average of any value, what you take? If it is of same type. So your velocity is not of same type but velocity is uniform. It is having uniform motion means equal displacement in equal interval of time. Equal displacement in equal interval of time. Then that velocity is said to be uniform velocity. Okay, so during that we have to find average velocity of that particular given values. So if velocities are given to you, initial velocity and final velocities are given to you, or by knowing if number of values are given to you, out of that just take initial velocity, final velocity and divide it by 2. This is the way we find average. So average velocity we can say, so these are two number of velocities, hence divided by number 2. Okay, so if velocities are directly given, then you have to use for uniform velocity this equation, and if velocities are not given to you, displacement are given to you, so you can use both the method. Okay, so what you can do, go by this method, means in particular time t1 what is the displacement, in particular time t2 what is the displacement d2. If you come to know that all the values are same, displacement d1, d2, d3 and so on are same, and time t1, t2, t3 are same, hence the velocities will also be same. So find initial velocity, find final velocity, or any one velocity you can find, plus divided by 2. So this is for uniform velocity. So when we go through the problems, we'll come to know how to solve such questions. Okay, so uniform velocity means equal interval, in equal interval of time, equal displacement covered will be called as uniform velocity, and non-uniform velocity means when unequal displacement is covered in equal interval of time, so it is called as uniform velocity. Plus for speed also the same definition. Okay, now let us go for a few simple examples we will take. Okay, okay, so let us take this example. Raj swims in a pool in a 90-meter long pool. He covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Okay, now here let us find the average speed and average velocity of Raj. Okay, so very first we will check what things are given in the problem. Whenever you are solving any physics problem, go through each and every word, because the words are very important. It gives you direction, it gives you many links. So it is very important to concentrate with full concentration. Just watch what things are given to you. If your given part is correct, then 50% of solution you will get of the problem correct. Why? Because if given values are not given, you have to check whether the SI units are same. Okay, then the things given are, if we are talking about motion chapter, then the direction is needed so that we can get its displacement. Okay, so we'll see this problem. Raj swims in a 90-meter long pool. So the length of pool is how much? This is length of the pool, 90-meter long. So this length is how much? 90 meter. Now he covers 180 meter. Okay, Raj is covering how much? 180 meter in 1 minute. Time how much he is taking for covering 180 meter? 1 minute. Don't get confused in this 90 meter and 180 meter. Read the question very carefully. Raj swims in a 90-meter long pool, swimming pool. So we came to know that the swimming pool is 90-meter long. Okay. He covers 180 meter in 1 minute. Means distance covered is 180 meter and how much time has been taken? 1 minute. By swimming from, okay, now this is the important part. By swimming from one end to the other and back along the same straight path, means from here Raj started, and very important word here used is same straight path, means Raj started from here, okay, 90 meter, and again return back to its original position by the same straight path. Okay, so what you have to find? Average speed and average velocity. Okay, so it's very simple. For finding speed, what is the formula we use? Distance upon time. Average speed also you can use the same equation I already said. Total distance covered upon total time taken. Why we are using this? Because here we don't have in packets the distance given and time given in packet. It's one time given you total distance covered and total time taken. So in this case it's very convenient for us to use the formula total distance covered upon total time taken. Very first I have drawn this diagram because it makes little easier. Second thing, while writing given, I have to be very look to each and every concept given. This 90 meter is not useful for us for R because we are finding whose velocity and speed of Raj. So actually the swimming pool is 90 meter, but he is covering 180 meter in 1 minute. So very first we will see distance covered. Distance covered by Raj is equal to 180 meters. So I can say this is total distance covered because he is covering when he goes from one point to another point. Okay. And if 180 meter is not given, still you have to understand he is moving the 90 meter long swimming pool. He is starting from this point, again going using the same path. So 90 plus 90 it becomes 180 meter. Okay. Okay. Then so for covering this distance, how much time it is you taking? Time required 90 meter. Okay, so what we have to find? Average speed and average velocity. Put question mark for this. Now we will start the solution. Formula for average speed is equal to total distance covered upon total time taken. Okay. So how much is the distance? 180 meter. And how much is the time? 1 minute. Oh sorry. By mistake I have written a 90 meter. 1 minute. Okay. So 1 minute here SI unit is meter. Okay. But is this minute SI unit? No. Its unit should be 60 seconds. So 1 minute is equal to 60 seconds. Okay, by mistake I have written here 90 meter. Actually it should be 1 minute. So 1 minute is equal to 60 seconds. So now this is SI unit, meter, and second is also SI unit. Conversion is very important. So 1 meter means how much? 60 seconds. 0 0 get cancelled. 6 1s are 6 3s are. So 3 meter per second. So average speed is equal to 3 meter per second. Correct? Now let us go for second question. Average velocity of Raj. Okay. Average velocity of Raj. Okay. Now here again average velocity values are not given, directly one value is given. And you know what is formula for average velocity? The same thing. Displacement upon time. Total displacement upon total time taken is called as average velocity. Okay. So here let us check the displacement. Now this is very important to see. Here displacement means what? Shortest distance between initial and final position. Word I am repeating. Shortest distance between what? Initial and final position means this is initial and this is final position. But let us check here Raj what he is doing. He is moving. That's why I said you have to check. He is swimming from one end to the other and returning back to its original position. So here its initial position is this, and where it is coming back, again it is coming to this position only. So initial position and final position is the same. So here displacement covered is how much? 0 meter. Why 0? Again I will repeat. Here the person who is swimming, Raj, started from this point. So this is initial position. Again by the same straight path it is going back to the original position. Okay. So final position and initial position is the same. Hence displacement is no displacement, or I can say 0 displacement. Its value is how much? 0 meter. And time is same, 60 seconds in 1 minute. So it comes 0. So your velocity is 0 meter per second. So average velocity is equal to 0 meter per second. Okay. So this is the final value. Average, therefore average speed of Raj is 3 meter per second and average velocity of Raj comes 0 meter per second. Okay. Let us see now one more question. So displacement many times may be 0, but you have to check how and when the situation becomes that it comes 0. It's very simple. When it will come 0? Whenever initial and final position of that particular object, of that particular any object given, person given, comes 0, then the displacement is 0, hence velocity will also come 0. Okay. Let us see another problem. Okay. Let us take another example. Again, it's an interesting problem. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds. Okay, so an athlete completes one round of a circular track. Okay, this is another point, another type of problem we are going to solve. An athlete completes one round, okay, of a circular track of diameter, what is its diameter? 200 meter in 40 seconds. Means for one round, how much time is required? 40 seconds. So this is the rough work. You need to do it while solving any type of problems, such word problems, okay? So it makes little easier and you can imagine all the things, okay? If you make pictorial representation of given question, it will be very easy for you to solve the problems, okay? Now I came to know that it's circular, its diameter is 200 meter and it takes for one round how much time? 40 seconds. Now let us say what is given. What will be the distance covered? So this thing you have to find, and the displacement at, now here the point is at the end of, here now the time has changed. They are not asking for this particular time, they are asking for another time how much distance and displacement is covered. So here time required is how much? 2 minutes 20 seconds. Okay, so very first we will draw the diagram, after diagram given values. Okay, very first diameter is given to you. Diameter is equal to 200 meter. Okay, so I will leave some space. What to do and why I will tell later on. Okay, just we are not known to anything and we are trying to solve a question given to you. Diameter is given to you, that is 200 meter. Okay, then time for one round, time required for one round is given 40 seconds. Okay, how much time it requires? Time for one round 40 seconds. Okay, then distance covered, you have to find distance covered in 2 minutes 20 seconds and displacement in 2 minutes 20 seconds. Okay, so this is our problem. Okay, let us find solution for it. Very first, distance covered in 2 minutes 20 seconds. So let us first make simple thing. This is in minute and second, so we can convert this minute into second. So whole part we have to convert in SI unit. Okay, then distance is asked, distance covered in 2 minutes 20 seconds. Okay, now let us see how much distance is being covered or distance travelled is for of how much rounds. Okay, so time first for finding distance covered in 2 minutes 20 seconds. Okay, so time is equal to 2 minutes 20 seconds. So 2 minutes means 2 into 1 minute. This 2 minutes means 2 into 1 minute plus 20 seconds. Okay, so 1 minute makes how much seconds? 60 seconds. plus 20 seconds. Okay. So 2 into 60 means 120 seconds plus 20 seconds. Total it becomes 140 seconds. So time for covering that distance is how much? 140 total seconds. Okay. Now 140 seconds is total time required for number of rounds. Okay, means in this much time we have to find how much distance will be covered. Okay, so what is the simple method? So we are going to find distance is nothing but, here the person is supposed starting like this. Okay, so this circular track is nothing but the circumference of circle. Correct? It is what? Circumference of the given circle. So let us see now how many rounds he will complete. Okay. So 140 seconds. 140 seconds means if for one round it requires how much time? Diameter in 40 seconds means one round it requires 40 seconds. Okay. So let us see how much round it will take. Okay, so it is 3.5 round. Okay, so how much round that particular athlete is in 140 second? It is completing 1 round, 2 round, 3 round and 3.5 round. So it's very simple. Distance covered is equal to your circumference of the circle. Circumference into how many times? How many times it is covering that circumference? 3.5 times. Now 3.5 times. What is the circumference of circle? You have studied in maths. 2 pi r into 3.5. Okay. Now last part. 2 pi r means 2 into 22 by 7 into radius. That's for this situation I have left this space. Now radius is equal to d by 2. Okay. So 200 by 2. It is how much? 100 meter. So let us substitute 100 into 3.5. 7 ones are 70.5. Okay. 44 into 100 into 0.5. Again it becomes 4400 into 0.5. So it's very simple. 2200 meter. So distance covered is 2200 meter. Now let us see displacement. Displacement is equal to, okay, actually we have to see for displacement initial and final position. Okay, how much round? 3.5 round. 1 round, 2 round, 3 round. Again coming, see, for first round coming back to its original position, displacement will be 0. For second round again displacement will be 0 because initial and final position is coming the same. That's why displacement is 0. In the third round again the initial and final position is the same. But for half round it will complete how much? Only this much portion. This much. Okay. So here this much is the part covered. So this will be the initial position and this will be the final position. Okay. So what is displacement? Shortest distance between initial and final position. So this much is the displacement. Hence displacement here is nothing but the diameter of the circular track. Therefore displacement is diameter of circular track. And it is given how much? 200 meter. So distance and displacement comes different in both the cases. This is very nice, very nice problem. And in this way for square also you can find. Okay, if there is any square field, so we'll take such problems also. But these two problems you need to do again and again. Okay, such problems you have to handle by your own. until and unless you will not understand what situations are coming while solving the problems. Okay,